Hello everyone, today we got some real geometry. Alright, so here we got a nice shape and we're asked to find the proportions of these two lengths, given the information that the line CD splits the line segment AB into proportions 1 to Q, meaning that BD over DA is equal to Q, and the same goes with this line here splits that line, so we have that CE over EA is equal to P. So now, of course, we need to find an expression for DF over FC using P and Q. So how do we do that? Well, to do this, we add a nice line. We add a line that's parallel to AC here from D. So we do that. So I add a nice little line here and claim that this is parallel. So it goes all the way through here. Yeah, get the point. And now, what do we realize? Well, it's quite obvious that these angles are the same. But how about these two angles? Are they the same? Well, it is quite obvious in hindsight, for me at least, to say that they are, because these two lines are parallel and this is the same line. So it's quite obvious that these two angles, now I'm drawing in the D here, this angle is the same as that, and that angle is the same as this. So these two angles are also the same, and therefore the last one is also the same, meaning that these two are similar. And now, what can we do with that information? Well, we want DF over FC, but since we know that these triangles are similar, we can just take any proportion as long as we're comparing the same side. So we could, for example, we could take that, this divided by that would work. Or we could also take this divided by that, and this is the one I'm going to choose. So I'm going to create a point here. I'm going to call it G. And then, so we want that DF over FC is equal to, yeah, here I have some space, kind of, is DG over, yeah, I'll say CE. And what I hope now to be able to do is express this solely in terms of P and Q. So, okay, CE, we can just exchange that from here to be EA times P. So, okay, DG, we have P times EA. Okay, so that's nice. Then what do we have here? Okay, we have DG over EA. This relationship, oh, that looks really nice. See, these triangles, the triangle DBG is also similar to ABE, of course, since these lines are parallel. So therefore, this divided by that is the same as this divided by that and this divided by that. And since we have, okay, we have BD and BA, looks like we can use Q, right? So we say that, okay, DG, that's the same, sorry, DG over EA, that's the same as BG over BA. So I'll continue over here. That's the same as, what did I say? BD over BA. Yeah. BD over BA, and it's P times also down there. And now this can actually be expressed completely in Q. How? Okay, firstly we need to move things around a bit. Okay, so we exchange BA for well, it should be, well, yeah, okay, it's just BD plus DA, and then we can exchange all the BDs, sorry, end parentheses, we can exchange all the BDs for Q times DA. So what we would get left is, so I'm extracting the 1 over P, then I would get times, okay, so BD is Q times DA, and then BD is, as I said, Q times DA, and DA is just DA. And here we can see that all DAs cancel out, so what we get left is just Q over P times 1 plus Q. And now, fuck, that was a bad parenthesis. Here, parentheses, 1 plus Q. And that is our definitive answer. And then you might ask, okay, but what if we asked about the other proportion instead of asking how this line segment gets splitted? We ask instead of how this gets split. Then you would as intuitively guess that we just switch the positions of P and Q. And that would be the correct answer. Or maybe not, please tell me otherwise. I think so, at least. So yeah, that was that was that was it. And hope you enjoyed the problem. I like this geometry problem more than the last one. This was at least a bit harder. So yeah, that was everything. Hope you enjoyed the video and have a good one. Bye bye.